Friends, engineer, consultant, and architects and students. Once again, this is VK Jain dictating module F3 of external fire hydrant systems. In the previous module, we have learned about whatever internally firefighting arrangements are to be made. But in this particular series, will be dealing with the external fire hydrant systems in a campus. In a campus, there may be many different type of buildings, maybe rectangular, circular, or any other shape. We need to provide a ringman type of system in the entire campus, which will extinguish the fire if it happens externally to any building in the campus. We have to keep in mind that in any campus for light hazard we provide hydrants at every 30 meter in a ringman fashion. Ringman fashion means you can feed the water from both the sides. So let us continue. Friends, before we go into details of this series, uh, let me tell about the composition of National Building Code 2016, which is divided in two volumes. Each two volumes, roughly to 2,200 pages. In the volume 1, we have part 1 as giving definitions of terms to be used throughout the building code. Part 2 dictates administrative requirement. Part 3 um, provides the detail of development control rules and general building requirements. Whereas it is this part 4, fire and life safety, which is with which we are concerned in this series. You will find all type of rules and regulations and requirements of fire and life safety in this particular part. The part 5 is building material, part 6 is structural design. In this particular slide, we are seeing external hydrant system as per Indian standard 13,039 of 1891. External hydrant systems provision and maintenance code for. As per National Building Code of India 2016 Part 4 Fire and Life Safety, yard hydrants provide external firefighting capability for fire brigade operations around the building, ensuring accessibility of water within the site. Now, these external yard hydrants are designed in a ringman fashion in the entire campus, taking care that every building external portion is protected by this system. This table 23 of National Building Code 2016 Part 4, water demand is given depending upon different type of buildings. The chart shown below in column 1, the occupancy type is mentioned, and in column 2, minimum hydrant water demand is given in liter per second or liter per minute. We can see that for residential, educational, institutional, and small business buildings, the requirement is uh, 900 LPM liter per minute. In case of assembly buildings, hotels, large offices, and medium industrial, the requirement is 180 LPM. In case of large industrial warehouses and high hazard, the requirement goes 270. Minimum duration of supply is taken as 3 hours. Friends, in this particular slide, we'll deal the different aspects of yard hydrant system. Yard hydrant system is always external and it is designed in a ring-wound fashion for fire protection system in industrial complexes, power plants, and large building development also. The purpose is to provide a reliable and continuous water supply for firefighting, ensuring sufficient pressure and flow even if one section of the pipe network is damaged. It is designed in a ring manufacture, so water can go in either direction. The main piping is laid in a loop formation around the perimeter of area to be protected, typically underground. By underground I mean the ring pipe has to be provided underground. The components of this entire yard hydrant system are pumps, a fire tank, and the main piping network, isolation valves, and the yard hydrants themselves. The yard hydrants are vertical standpipe type, known as standpost function. When a hydrant valve is opened, the resulting force automatically starts the fire pump supplying high pressure hose connection. Friends, this particular slide shows a requirement of yard hydrant system. As per Indian standard IS 13039 of 214, yard or external hydrant for provision and maintenance, while the landing valves should conform to Indian standard 5290 of 1997 type A, featuring gunmetal construction, instantaneous connections, and positioned about 1 meter above ground level on the stand post, often with bollard for protection. Bollard means electrical fittings, ensuring accessibility and adequate water flow for industrial and large premises. Spacing: hydrant should be 30 to 45 meter apart, 30 meter for high hazard and 45 for moderate hazard. Every point of building perimeter must be within hose length, that means from hydrant plus hose. Height of the hydrant post is 1 meter above the ground level. Coverage. All building sites accessible for fire. Friends, we are discussing the fire service inlet to be provided to facilitate the fire brigade or the local trained staff in case of heavy fire. The following facility or arrangement should be applicable to fertilizer system. 1. A fire service inlet at ground level fitted with a non-return valve must be provided to the rising man of each zone for charging it by fire service pumps. In case of failure of fire pump, if two rising men are within a distance of 30 meters horizontally, a single fire service inlet will be sufficient. 2. The fire service inlet should be located and arranged on street side on the building, preferably near main entrance, prominently marked and without any obstructions so that fire service can connect hose lines without difficulty. Fire service means fire brigade or the local fire service. Third, the inlet should be located inside a box made of 1.6 mm mild steel plate with openable 4 mm thick glass frontage with locking arrangements. The word the words fire service inlet should be written in letter at least 75 mm in height and 12 mm in width in fluorescent color fire red. This slide shows 4 inlet fire brigade connection at the gate of building complex. It is uh, for inward gate of the building complex. A 4 inlet connection must be provided so that fire brigade can connect 4 connections of their fire tender. It has 4 different connections which can be provided, and this 4 inlet connection is directly connected to the inside static water tank. Friends, on the top of this slide, a 4 inlet connection is shown in which two inlet connections are provided with the cover and the other two are shown without the cover, and these covers are here. Sometime we may have to provide a three-way fire brigade inlet connection as shown on bottom of this slide. These are provided in a building which are away from the main ring van connection of the premises. Friends, this particular slide shows how the inlet connections are fed water from fire brigade vehicle. Friends, this slide shows a pedestal type hydrant system having two valves on the left hand side, in which you can feed it horizontally, and on right hand side you can have the connection at 30 degree. Friends, this particular slide shows us man ex- external hydrant piping known as yard hydrant as per National Building Code. The mains should be of cast iron pipe or mild steel. That means I'm talking of the ring man to be provided. Underground mains should not be less than 1 meter below ground level. Where soil conditions are unsatisfactory, masonry or equal support should be provided at regular interval. Above ground mains should be adequately supported at regular interval, not exceeding 3.5 meter. When located near building, the mains should be at least 2 meter away from the face of the building. The fire hydrant mains should always be in rings or cross-linked rings. That is, all the mains should be interconnected. However, the minimum size of mains should not be less than 150 mm in diameter. Friends, this particular diagram shows a pedestal type standalone external hydrant system, which is provided with two hose reels, canvas type, each of 15 meters, so that you can take up to 30 meters away from the hydrant system. This particular diagram shows the main components of a ringman yard hydrant piping system, in which there is a fire tank, and from fire tank through the pump the ringman is fed. It is called ringman because you can take water in either direction in case some portion becomes faulty. The diagram shows various standpipes at regular intervals. Friends, this particular diagram shows how the several different type of buildings are to be protected through a yard hydrant external system, in which several stand pipes are shown. They are shown 30 meter for 30 meter for heavy this one, and 45 for moderate hazard systems. That means the distance, this distance should be either 30 or 40, 45. In this, we provide a 200 diameter ringman system in the campus, just at the boundary, near the boundary, but 2 meters away. This distance should be 2 meters. Now several buildings are protected this, and this ringman has some extensions if the building is more than 22.5 meters away from the ring system. These are known as bridge connections. I have shown here. There is a 4 inlet connection provided on the entrance gate that is always on left side. The 4 inlet connection is shown here, through which water can be supplied to static water tank directly, eh, and it keeps it always full all the 365 days and 24 hours. Uh, we have to strategically locate the standpipes even if the distance covered is less. But strategically on all corners, these are provided in all the 4 corners. Friends, in this slide, I am showing a real life campus of a healthcare system, medical college, 100 bedded at some particular place, in which you can clearly see the yard hydrant system provided in a ringman fashion in the campus, and the standpipes denoted by HB are strategically located so as to protect each and every building in the campus. This one is to take care of this, and this one is to take care of this portion of buildings. This is denoted by HP. This ringman yard hydrant system is like this. Friends, so far we have discussed the yard hydrant system for a particular campus. But normally in towns or cities, the hydrant should be provided at interval of 100 meter, and this distance may be suitably increased or decreased depending upon the risk in the area desired to be protected. I am talking of the town planning aspect. No portion of the protected building should be more than 45 meters from an external hydrant, and where this requirement cannot be met, then suitable distances may be adopted. Friends, in this slide, I have shown a real life firefighting arrangement system of a particular campus in which there are several buildings are there. This is a medical college system in which there is an auditorium, cadet mess, cadet lifing. This is a military campus. So several buildings are here, and the facilities which are required to be provided when it is uh, when it is required, it is denoted by R. When it is not provided, it is denoted by NR. This is as per National Building Code.